The A320 is equipped with two air conditioning packs located in the wing root area forward of the landing gear bay. Let's look at how a pack works. Hot bleed air enters the pack via a pack flow control valve. The purpose of this valve is to adjust the flow rate through the pack. The air then passes through several stages within the pack that progressively cool the air to provide a conditioned air output. In fact, sub-zero temperatures can be achieved. Two of the stages are heat exchangers that use a flow of ambient air over them to cool the hot bleed air. This flow of air enters via a pack inlet scoop and exits via an outlet duct. So that the output temperature of the pack can be adjusted, a bypass valve is fitted. This valve allows warmer air to be mixed with the cold air. Note, the bypass valve provides for greater fuel efficiency. Since the pack in many circumstances can be bypassed, less bleed air is needed from the engines. Thus, less thrust is needed and therefore less fuel. The pack flow control valve and the bypass valve are regulated by the pack controller to vary the flow rate and temperature output. The pack controller also controls the inlet scoop and outlet duct to vary the amount of air passing over the heat exchangers. Note, to avoid ingestion of foreign matter, the inlet scoop and outlet duct close temporarily during takeoff and landing. The two air conditioning packs operate automatically and independently to provide cool conditioned air. The conditioned air from the packs is then fed to a mixing unit. In case of failure of both packs, ram air is provided via a ram air valve. We will look at the use of ram air in the abnormal operation module. Various pack parameters are monitored by ECAM. They are pack flow, compressor outlet temperature, bypass valve position, pack outlet temperature. These parameters, along with the valve positions, are displayed on the upper part of the ECAM bleed page. Having discussed the air conditioning packs, we will now look at how temperature and flow regulation is achieved throughout the aircraft. The three outputs from the mixing unit feed three separate aircraft zones: cockpit, forward cabin, and aft cabin. Let's look at how the temperature of the zones is managed. A zone control computer monitors the temperatures of the three zones and sends signals to the pack controllers to set the air temperature delivered by the packs. Normally, cold air is delivered by the packs and is then sent to the three zones. Since the different areas of the aircraft may require different amounts of cooling or heating, hot bleed air can be added via trim air valves to achieve the demanded temperature for a zone. In the example shown, no hot air is being added to the cockpit zone. Some hot air is being added to the forward cabin zone. A lot of hot air is being added to the aft cabin zone. The trim air valves are supplied via a hot air valve. The purpose of this valve is to regulate the pressure of the hot air supplied to the trim system and to act as a shutoff. The hot bleed air is supplied to the hot air valve from just downstream of the pack flow valves. This means that if the pack flow valves are closed, there is no air supplied to the trim system. The hot air valve and the trim air valves will automatically close. The trim air valves and the hot air valve are controlled by the zone control computer. Zone duct temperature, which is the temperature of the air entering a zone, and the actual zone temperature are monitored by the zone control computer and presented on ECAM. The ECAM conditioning page contains zone temperature and trim air system indications. The ECAM cruise page also contains zone temperature indications. On the overhead panel, there is an air conditioning panel which allows pilot control of the air conditioning system. Let's look at the controls on this panel in a little more detail. The pack flow switches control their associated pack flow control valves. In the example shown, pack 1 is selected off and is indicating closed, while pack 2 is selected on and is indicating open. The pack flow selector permits selection of desired pack flow. The guarded ram air switch controls the ram air valve. In the example shown, the ram air valve is indicating closed. Use of the ram air switch is restricted to abnormal conditions that will be discussed later. The hot air switch is associated with the hot air valve. There is a hot air valve indication on the ECAM conditioning page. In the example shown, the valve is indicating open. Now, let's look at temperature control. The zone temperature selectors are used to adjust the required temperature for an associated zone. 2 cabin fans are fitted to reduce the bleed air requirement and therefore save fuel. These fans establish a recirculation flow of air from the 3 aircraft zones to the mixing unit. In normal operation, there are no ECAM indications associated with the cabin fans. On the overhead panel, there is a cabin fan switch on the ventilation panel to control the cabin fans. The cab fan switch can be used to switch the fans off in response to ECAM procedure. The conditioning of the air in the cargo compartment is fully automatic. Ambient air from the cabin area enters the cargo compartment via an inlet isolation valve. The air is removed from the compartment either by an extractor fan or by differential pressure. The air is discharged overboard via an outlet isolation valve. The operation of the isolation valve and the extraction fan is controlled automatically by a cargo ventilation controller. To provide heating of the cargo compartment, hot bleed air is supplied via a trim air valve. The operation of the cargo trim air system is very similar to the trim air system for the air conditioning system. A cargo heating controller controls the trim air valve position to regulate the temperature of the compartment. The information is presented on the ECAM conditioning page. The cargo heating system is an extension of the air conditioning system. hot air is routed via an independent hot air valve for the aft cargo hold. The system has a trim air valve and 2 isolation valves, which close immediately should smoke be sensed, thus turning the aft cargo bin into a Class D compartment. The trim air valve is identical in operation to the trim air valves for cabin conditioning. It is used to add or subtract hot air. Duct temperature and cargo compartment temperatures are shown on the ECAM page. On the overhead panel, there is a cargo heat panel that contains the controls associated with cargo heating and conditioning. This is the isolation valve switch. This switch normally remains in the open or lights out position. The temperature selector sends demand signals to the cargo heat controller. The cargo heat controller then moves the trim air valve to adjust the temperature of the air entering the compartment. The hot air switch controls the aft cargo compartment hot air valve via the aft cargo heating controller. This switch also normally remains in the lights out auto position. For normal operation of the cargo conditioning system, the only pilot inputs required are to confirm that the switches are in their normal lights-out position, to set the required temperatures. Note that the mid position of the temperature selector is approximately 60 degrees Fahrenheit.